Hi everybody, this is Stephen-Castro. I'm one of the nursing faculty here at Kansas Community College, and I am going to go over dimensional analysis with you. I created this PowerPoint kind of to serve as a self-study module with lots of practice questions, and it includes the answers so you can check your math after you're done. It's all set up in dimensional analysis, and hopefully it will be somewhat easy to follow. If you've had dimensional analysis before, usually it's not too hard if you were trained, if your brain was already trained to do dosage calculations in this method. If you're from the old formula type, sometimes that transition from using the formulas to dimensional analysis can be a little difficult. If you need some more one-on-one attention, there are several instructors around that are quite well-versed in dimensional analysis. And my office is always open. Feel free to shoot me an email, and I can see if I can set up an appointment with you to go over some things with you as well if you need to. All right, so let's go ahead and get started. Again, this PowerPoint is really designed to be interactive. Okay, there's some links and some other videos embedded into the PowerPoint, so it's really embedded for you, the user. All right, our objectives. What is our goal for you once you finish this PowerPoint or go through the series of of slides here? Number one, we want you to be competent in doing those drug calculations. It's imperative that we take our time, check it once, check it twice, make sure you're doing all the rights of medication administration, and that is also including verifying the dose for your clients. We're going to have some basic principles related to old basic math and algebra. We're also going to kind of identify why it's a real advantage to using one standard process to do your drugs and dosage calculations versus trying to memorize multiple formulas. You should already have your units of measure memorized. If not, you should probably review that before you proceed through the PowerPoint. I do have some slides dedicated to that as well. And then we're going to get lots of practice to calculate some of those drugs dosages as well. Because again, we want to give safe and effective doses of medications to our patients. Again, why do we do dimensional analysis? And there's, evidence-based practice. It just really boils down to that. If you haven't heard that term before, you will hear it multiple times throughout your nursing education. Frequently, a lot of the what we do, nursing is driven by evidence-based practice. We see what the best practice is out there, and that's why we do it. We don't just do things because we feel like it. We do it because the evidence tells us this is what's best practice for our patients. And using dimensional analysis has been proven to be the best practice for dosage calculations. It is a foolproof method if you do it appropriately, do it correctly. And it's, one standard method where you don't have to memorize multiple formulas again. And you really can use it for all equations. You just have to learn how to set up your problem. Okay. All right. Moving along. Feel free to read over all the reason why we do dimensional analysis. I'm not going to go through each one of those specifically. Here's some abbreviations that you should be familiar with. Please review those. These are approved medical abbreviations. Please note the one that's written out on there is unit. We used to write U, but there was a lot of problems using the U for units in the past. There's a lot of mistakes made, so units must always be written out. Just kind of please be aware of that. And these are your standard abbreviations that you should be fairly familiar with. These are pretty common. Here's some units of measure. And most of these are in the metric system. Notice we don't have a lot of like the deciliter and the hectoliter and all those other things. We really don't use those with dosage calculations. These are the ones that you'll most commonly see, and that's going to be liter, kilogram, milliliter, milligram, meter. We really don't even use kiloliters that often. Millimeter, gram, microgram. Okay, so please review your units of measure. You should also know your conversions for your units of measure. Just kind of a review of the conversions. Remember, 1 kilogram is 1,000 grams, 1 gram is 1,000 milligrams, 1 milligram is 1,000 micrograms, and 1 liter is 1,000 milliliters, and so on and so forth. I'll let you read through the slide. But the ones that I have on here are typically the ones that you'll be using most commonly for drugs and dosages. The only other one that you might see pretty frequently is kilograms to pounds and pounds to kilograms. Okay. Other equivalents, and again, some of these are pretty common sense. We do use the 30 milliliters to 1 ounce, and sometimes we may have to use milliliters to teaspoons or tablespoons, so we can let, especially if we're giving medications to, or giving medication teaching to our clients at home, because they won't typically use those units of measure at home. They'll use teaspoons and tablespoons. So just go ahead and review that as well. A little review. I'm not going to go through all the answers on here, but you should be able. This is pretty basic. Just converting your kilograms to pounds and vice versa. Take some time and just kind of practice that. If you haven't done it in a while, if you feel like you're really well versed in making your conversion from kilograms to pounds and vice versa, feel free to move on through this slide. All right, dosage calculations has 2 main components, and it's no different than that formula. You have desired over half, and what you have your dose on hand. So what's desired over what you have, or your dose on hand. Those are basically what the 2 components to dosage calculations. The medication dosage, that's what's going to be prescribed by the doctor. That's how much of something someone's going to get, and usually it's written in strength form, like milligrams and so on and so forth. And then the concentration is typically how it's supplied by pharmacy, or how that medication is delivered, or how it comes. Remember, concentration is not necessarily a fraction. It's really set up more like a numerator, and a denominator. And they can be flipped back and forth. If you remember chemistry, and you used to be able to convert your moles and so on and so forth, it's the same process that we're going to use here for drugs and dosages. Kind of consider your milligrams, micrograms. Those are considered like exponents. And you set up your problem, and if you have milligrams on the top and a milligram on the bottom, those exponents will cancel out. And so hopefully, if you've built your problem correctly, and it's going to make more sense here in just a minute, if you've built your problem correctly, all your exponents will cancel out, and you'll be left with the unit of measure or measurements, or whatever the question's asking. You'll have that at the end. I know it kind of sounds a little bit more difficult when I'm trying to explain it to you, but when you see it in action, it typically makes a little bit more sense. All right, so how are we going to set these up? We typically start with the given single measure on the left side of the equal sign. And then, so I always kind of like write my equal sign out, or on my one side, I always like, what information am I given? What is this question asking me? And what I figure out, what is this question asking me? Is it asking me to solve for milliliters per hour, or just tablets? Or am I trying to figure out how many micrograms per minute? What am I solving for? What is it asking me to solve? And once I figure that out, then I'm going to put that on the right side of my equal sign. And then we have to identify the equivalence of measures. Do we need any conversions in our math problem? And then we just kind of figure out, kind of make it look like similar to what a fraction would look like. And you put your units of measure either in the numerator or the denominator, so they'll cancel out, and so you'll be end up with what you need. And then you just multiply everything on the top. You're going to divide everything on the bottom. and then you'll finish the problem, and then that should give you your answer. And again, it sounds confusing when you try to explain it to someone, but when you actually see it in practice, it's pretty darn simple. Alright, so now that I probably completely confused you, let's go ahead and try putting it to practice. And we're going to start off with some very basic things that you could normally just do in your head, but we're going to do it in the style of dimensional analysis, so that way you can get the practice of how to use it. Alright, so we're going to start off with some dimensional analysis and basically like ratio proportion, more or less. Again, courses like chemistry and physics have had you learn to change one unit of measure to the other. You change, micrograms to milligrams and milligrams to grams, and they probably do hecto and deci and all those other things. But we are just going to use some basic micro, milligram, gram, and kilogram. That's basically kind of the only really units of measure that we really use for the metric system and liters in dimensional analysis. Alright, so all those same principles are going to apply here. Those top 3 questions on the top are all set up like dimensional analysis. The bottom one, where it has cups of sugar versus cups of flour, like if you have a recipe and you have to double a recipe or half a recipe, that's the same thing. You're doing a ratio proportion. If you have 1 cup of sugar to 2 cups of flour, if you have 2 cups of sugar, you're going to have 4 cups of flour. That's considered ratio proportion. Okay. I've got a little short video to play for you about the questions on the top, and I'll go ahead and play that now. Okay. Alright, so here we have some basic dimensional analysis and ratio proportion. And I know that most of you guys can probably do this in your head, but I'm going to go ahead and go over some of these with you, and they're already kind of written out here on the screen for you. So, we want to know how many inches or how many feet are in 24 inches, or how many feet does 24 inches make up. So I'm looking at this second one right here. So we're setting this up in the dimensional analysis method. So 24 inches is what we're given, and it's asking us how many feet. So 24 inches is what we're given. Our conversion is 1 foot is 12 inches. I set it up where the inches are diagonal for each other, or from each other. The inches will cancel out. You're left with foot by itself, and that would give you the answer, which would be 2. And then our second problem over here, you have to know how many seconds are in 1 day. So again, we've set up all these conversions so we know, can do the math to figure out how many seconds are in 1 day. So 1 day is what I'm given. I want to end up with seconds all by itself. So I want to make sure that's on the top. So in 1 day, my conversion is 24 hours are in 1 day. And I set that up diagonally so the day will cancel out. Whoops. I clicked on that. And then I have 24 hours here, but I still need to get to seconds. So 24 diagonally from that is its conversion. 1 hour is 60 minutes. The hours will then cancel out. And then I've got minutes on the top. But now I still need to get to seconds. So I'm going to do one more conversion. 60 minutes. And then put 1 minute is 60 seconds. That conversion's to the right. My minutes will cancel out. And then I'm left with seconds by itself. So if you look at this whole problem, the days will cancel, the hours will cancel, the minutes will cancel, and it's left with seconds all by itself. And that's what we are solving for. We are solving for seconds. So now that I know I set my problem up correctly, you just multiply 1 times 24 times 60 times 60, and then you divide by 1, 1, and 1, which you all know that if you divide by 1, it's going to be the same number. And if you do the math for that, that's going to be like 86,400 seconds. And I do have the answers listed on the notes below. So, on the bottom, the cups of sugar versus the cups of flour. Like any recipe, if you have to double it, or maybe you only want to make half, that's considered ratio proportion. If I have 1 cup of sugar to every 2 cups of flour, maybe I want to quadruple my recipe. If I have 4 cups of sugar, how many cups of flour will I have? And so on and so forth. That's considered ratio proportion. All right, so let's move forward. I do have a set of practice problems here. When you have the PowerPoint open, you feel free to click here on this link, and it will open up some practice problems for you. And that is the end of section 1 of dimensional analysis. Again, we're going to start off really basic, and then we'll build up to the more difficult problems. Part 2 is we're going on into oral medications. Okay, feel free to read over the objectives. All right, we'll go ahead and start with the video. I'm going to expand my screen a little bit so you can see it in its entirety. There you go. Oops. And here we are. All right, so we're going to put some more dimensional analysis into practice. All right, so question number 1 here says, warfarin sodium, 5 milligrams PO daily. That is our order. The tablets is asking, how many tablets do we give? So tablets is what we should end up with. So we want to end up with tablets. Okay, so I'll put my tablets over here, okay? And it says, the label says 2.5 milligrams per tablet. So that's how it comes from pharmacy. Excuse me, kind of all tongue-tied today. All right, so warfarin sodium, the order is for 5 milligrams. And again, the label says it comes in 2.5 milligrams per 1 tab. So 1 tab is 2.5 milligrams. And if you look here, milligrams over milligrams, that means that exponent can cancel out. So I can just do 5 times 1 divided by 2.5. And you should all figure out the answer to that. It's pretty easy. That's going to be 2 tabs. Okay. All right, so we're going to move on to the next one. All right, nifedipine, blood pressure medication. It says 20 milligrams PO/TID. How many capsules will you give? And the label states 10 milligrams per cap. So it's asking us how many capsules. So again, I need to make sure my answer ends up in capsules. I need caps up here by itself. Okay, so let's set up our problem. Our order is for 20 milligrams. And it comes in 10 milligrams per 1 cap. So 1 cap is 10 milligrams. And you know 10, 20 times 1 divided by 10. And again, that's going to be 2. And of course you can do that in your head. But again, I encourage you to start setting this up with the dimensional analysis. So that way you'll get into practice on how to set those up and cancel things out like there's, and build a problem like you're supposed to. Okay. Okay. All right, amoxicillin, it says 75 milligrams, PO/QID. The milliliters, it says how many milliliters will you give? Because this is a fluid, this is in a volume, okay? The label states 125 milligrams per milliliter. Now this one you may have some trouble doing in your head, okay? So let's just work it out. Again, I need my answer to be in milliliters because it's asking me for the volume. So my answer needs to be in milliliters. So I need milliliters up here on top by itself. That's what I need my answer to be in. All right, my order is for 75 milligrams. So I know I need to put milligrams down here, and it comes to 125 milligrams in 1 mil. Okay, so my exponent will cancel out. So I know I built it correctly because I got mils by itself. 75 times 1 divided by 125, and your answer would be 0.6. Okay, 0.6 milliliters. All right, we're going to move on to question number 4. All right, potassium chloride, 15 milliequivalents PO daily. How many milliequivalents will you give? And when you hear the term milliequivalents, again, that is just a unit of measure. You'll hear that term if you haven't been exposed to it yet. You'll hear that term quite frequently. Potassium is given in milliequivalents along with a few other medications. So the order again is for 15 milliequivalents. It's asking how much will we give, and it's measured in volume, like milliliters. So we need milliliters over here by itself. Okay, that's how I need my answer to be in. So let's build the problem so I'm left with milliliters by itself. Order 15 MEQs, milliequivalents, and my medication is supplied by pharmacy, 20 MEQs, and 15 mils. Again, probably not something I could do in my head. So I would need to do this mathematically and set it up. So my milliequivalents should cancel out. So I know I've set it up correctly. So 15 times 15 divided by 20, and your answer would be 11.25 milliliters. Okay? All right. Okay. Moving along. All right. We have some more math problems. These I showed to show you a label, because obviously in the hospitals frequently you're going to be giving medications that may have a label, or they may be in a bottle. So let's go ahead and watch the video for that. All right, so now we're going to kind of go over some labels, because we know that sometimes in the math you can kind of pull out those numbers, but in actuality, when you're in the practice and you're in the units, you're going to have to look at labels. So get comfortable with looking at labels and looking at the information that you need to pull out from those labels. So on slide 18, which is what we're on, I have a couple of labels there, and we're going to try to figure out our dose from those labels. The first order on question number 1, it says it's written for metoprolol, which is a blood pressure medication, for 100 milligrams PO BID. How many tablets will you give per dose? And you have to look at the label. And the label says it's 50 milligrams. There's 100 tablets in the bottle. So we're going to go with that, okay? So again, it's asking how many tablets will I give? So I need to solve for tablets. Okay, so I need to make sure tablets is up here all by itself. So let's set up our problem. My order is for metoprolol, and I'm not going to 100 milligrams. And it comes in tablets. 1 tab is 50 milligrams. So 100 times 1 divided by 50. Again, you could probably do that in your head. That's going to be 2 tablets. Okay. All right, so let's look at label number 2. Label number 2 says order is written for naproxen, 750 milligrams. That is our order for 750 milligrams. How many tablets will we give per dose? So again, we are solving for tablets. So we're going to put tablets over here. We need tablets up here by itself for our answer. All right, so the bottle says you have naproxen sodium tablets, 500 milligrams. There's 100 tablets in the bottle. So you've got 500 milligram tablets. So it's 500 milligrams per 1 tablet. So my order is for 750 milligrams. And it comes in 1 tablet. We've got 500 milligrams. And again, I've set this up so my milligram and my exponents will cancel out, and I'm left with tablets all by itself. So I know I set my problem up correctly. 750 times 1 divided by 500. Again, if I can figure that out, it's going to be 1.5 tablets, okay, or 1.5. All right. We'll go with the next one. Okay. All right. And here's just some more information on milliequivalents. I've already explained it to you kind of earlier in one of the other videos. But again, it's just kind of a unit as measure, and it's abbreviated as MEQ. And it just kind of shows how many grams of a drug are in 1 milliliter of a solution. That's what that means, okay? The official definition. All right, so now we're going to do the same basic dimensional analysis, but we're going to add some conversions into it. We're going to go from grams to milligrams, milligrams to micrograms. So we're going to add those conversions in. So again, it adds another step to our problem. And this is frequently, if people are trying to move their decimal over or move it one way or another, I frequently see a lot of errors made when they use that method. If you use the dimensional analysis method, it is pretty consistent. And if you learn to set it up appropriately, you pretty consistently can get that correct answer with good practice. So let's go ahead and watch that video. Alright, so now we're on slide number 20, and now we're adding in conversions. So we're adding more complex issues into our problems, which is why dimensional analysis comes in very handy. So let's set these up. Remember, whatever it's asking us, we have to build our problem to answer our question. Okay, that's the most important thing. We've done some really basic things now, and you probably thought it's a little rudimentary, but again, we have to build our problem to answer our question. So question number 1, slide 20 here says, Norvir 0.6 PO BID, and that's an antiviral. We're going to give 0.6 grams by mouth twice a day, and it's supplied by pharmacy 80 milligrams per milliliter. So we're looking for volume, because milliliters is volume, and we also have a conversion because it comes in milligrams, but the dosage, the order is in grams. So we have to kind of put all that together, okay? All right, so again, I'm solving for volume. It's in how much are we going to give, so that's milliliters. So milliliters is going to be up here all by itself. That's what I'm solving for. So I need to set up my problem to answer for just milliliters alone. All right, my order, again, is 0.6 grams, okay? And it comes 1 milliliter, and we have 80 milligrams. Okay? Now, grams cannot cancel out with milligrams, so we have to add that conversion in here. Okay? This is where dimensional analysis is extremely handy. So, how many milligrams are in a gram? We talked about that earlier in the PowerPoint. You're going to have to commit these to memory. That's going to be 1,000. Okay? So, I need to set this up so these will cancel out. So, milligrams is down here. I'm going to do 1,000 milligrams, and that will cancel out my milligrams. And 1,000 milligrams, I have 1 gram, right? That's your conversion. So your grams will cancel out. Am I left with milliliters by itself? Absolutely. I know I built my problem correctly, so now I can solve it. 0.6 grams times 1 times 1,000 divided by 80, and my answer would be 7.5. That'd be 7.5 milliliters would be your answer. Okay, so let's go ahead and do number 2. Apologize about the sideway video.
All right, number 2, the order is for oxyprozin 1.8 grams PO once daily each morning. It's supplied by pharmacy, is 600 milligram caplet. How many caplets of this drug will be given? It's asking for caplets, so that's what I need to solve for. Caplets up here by itself. Okay, so the order again is for 1.8 grams. Pharmacy sends us 1 caplet is 600 milligrams. I've got to add in that conversion. So we've got grams and milligrams. To get these to cancel out, I'm going to do 1,000 milligrams up here and 1 gram down here. And that will cancel out my grams, my milligrams will cancel out, so I know that I built my problem correctly. So I'll multiply everything on the top, divide by everything on the bottom, and that will give you my answer, because I only have caplets left. 1.8 times 1 times 1,000 divided by 600, and your answer would be 3. Okay. All right, now we're going on to problem number 3. The last one on this slide. Problem number 3 says the order reads for defolitide 0.5 milligrams PO BID. Pharmacy supplies the medication in 125 microgram capsules. Calculate how many capsules of this drug should be given to the client. So it's asking again for capsules. So that's what I need to solve for. Capsules. Okay. So let's set up our problem. All right. Order is for 0.5 milligrams. Pharmacy supplies 125 microgram capsules. So 1 cap is 125 micrograms. And again, if you remember your conversions, how many micrograms are in a milligram? It's 1,000. Commit those to memory. So I need to set that up and put my conversion in here. So I've got 1,000 micrograms is 1 milligram. And that will set it perfectly where my exponents again will cancel out. And I'm left only with capsules, which is what I need my answer to be in. So 0.5 times 1 times 1,000 divided by 125, and your answer would be 4. Okay. Hopefully.
So, again, apologize about the sideways videos. I will re-record those. I didn't realize that my photographer had turned my phone sideways. So, yeah, we'll fix that. All right, moving on. Hopefully these don't turn sideways any longer, but we'll keep our fingers crossed. Alright, so dosages based on body weight. Let's go ahead and start with that video. I explain everything through there.
Alright, slide 21. Alright, so now frequently with pediatrics, some are geriatric patients, you're going to have to figure out medications that are based on weight. Okay, and we'll talk more about that in the actual PowerPoint. But let's put some of this to practice. So on slide 21, it says when an order is based on body weight of the client, so the client's typically going to be expressed in kilograms. We usually don't do things by pounds, and nursing, we do things by kilogram. So the order will probably indicate 5 milligrams per kilo, or 10 milligrams per kilo, or however many grams per kilogram. It's going to give you that specific information. And then that's your job to calculate the dose based on your client's weight. All right, so it says I have dilantin, or phenytoin, 15 milligrams per kilo for a loading dose, and then 300 milligrams per day. So we need to figure out what our loading dose is going to be for our client. And our client is 80 kilograms, okay? So if our client is 80 kilograms, remember, I want to set this up to answer for milligrams, okay? So I need to set this up that my kilos will cancel out, okay? All right, so my client is 80 kilograms. Notice I didn't start with the dosage first, because I have to set it up to answer for what my question is asking me. And you're going to see more of this as we progress and get into some more difficult problems. So it's 80 kilograms, okay? That's what my client weighs. And the order is for 15 milligrams per kilo. So 1 kilogram, 15 milligrams, okay? So do my kilos cancel out? They absolutely do. Am I left with milligrams by themselves? Yes, I am. So I know I set that up correctly. 80 times 15 divided by 1, and your answer would be 1,200, okay? And I know, again, you could probably just do that in your head, but I encourage you to set this up with dimensional analysis. And as you go forward with some of your weight-based medications, a lot of times you can't figure those into the problem all together at the same time. You need to get your dosage first before you actually build the rest of your program. Your problem, excuse me. So we just always need to get that dosage first, if that's indicated. Okay. That's it for that.
All right, we are moving right along. All right, again, here's another practice set for you along with some answers. So feel free to pause and click on those links on the PowerPoint and access those questions. And then if you're moving on, we're going on to section 3. All right, parenteral medications. Parenteral medications are those medications that are typically going to be given IM, sub-Q, or in some type of a liquid form, okay? And so we're going to calculate some of those types of medications. Please go ahead and read over your objectives. All right, just some general guidelines for infants, children, and adults. And you have to consider that's a normal adult. Sometimes we have our elderly clients, elderly females, even elderly males. They lose a lot of muscle mass and they're not real large. Sometimes you have to take that to consideration as well. So that tells us how much volume is really appropriate for that age group for subcutaneous medications and IM medications. All right, so let's go ahead and watch our video.
All right, so now we're kind of like talking about volume and IV medications or medications you're going to pull up in a syringe, okay? So those are typically all volume given, so you need to know how much volume to give, and that's usually going to be expressed in milliliters. So on slide 25, we have how many milliliters would you administer? So we have sandostatin, 50 micrograms subcutaneously every 8 hours. The label reads sandostatin acetate, 100 micrograms per milliliter. All right, remember, I'm solving for milliliters because that's my volume. All right, so I've got to set it up where I have milliliters left all by itself, okay? My order reads for 50 micrograms, and it is supplied by a pharmacy, and 1 ml, I've got 100 micrograms. No conversions are necessary because I've got micrograms over micrograms. I'm left with milliliters by itself, and 50 times 1 divided by 100, you can probably guess that that's going to be 0.5. Okay, Okay, so 0.5 mils for question number 1. All right, question number 2. We have clindamycin, 600 milligrams IM, Q12 hours. The label reads clindamycin 900 milligrams per 6 mils. And again, we're solving for the volume, but let's know how many milliliters are we giving. So I'm putting milliliters by itself, and it needs to be on the top. So let's set up our problem. All right, so order is for 600 milligrams, and it is supplied by pharmacy, 6 mils, and it comes at 900 milligrams. So my milligrams, that exponent's going to cancel out. 600 times 6 divided by 9, and your answer will be 4 milliliters. Okay? All right, we've got one more problem on this slide. Work through. Haloperidol. 3 milligrams IM Q6 hours. So the order reads for haloperidol 50 milligrams per mil. That's how it's supplied. So we are going to give 3 milligrams. So let's solve for that. We got 3 milligrams. That's how our order reads. And it comes 50 milligrams per mil. 1 mil is 50 milligrams. And this is a really, really tiny dose. Okay? So milligrams will cancel out and look at milliliters by itself. But if you did the math, it'd be 0.06 mils, which would be a really, really tiny amount. You have a really, really small syringe, like a TB syringe, but that would be your volume. Okay? All right.
All right. Moving along. Again, some parenteral medications have a shelf life, and that just means that they're not reconstituted prior to administration because they would expire really quickly. So let's go over that information for you.
All right, slide 26.
Oops. Sorry about that.
All right, slide 26. Reconstituting medications. Frequently, you will be given medications that come in powder form in a vial that you have to reconstitute. Usually it's medications that don't have a very long shelf life, and so you have to add the base to it or the base solution to it to dilute the medication so it can be administered, because it won't be on the shelf very long. It has a minimal shelf life. All right, so our order says for ampicillin 400 milligrams IM, how many milliliters will I administer? And you have a nice label to read, so this is really good practice. But remember, I'm solving for milliliters. That's what I need to know first. I'm asking for volume. And my order is for 400 milligrams. So that's my order. How does this medication come? It comes, the label says, add 1.8 milliliter diluent, resulting in a solution that will contain 250 milligrams of ampicillin per milliliter. Make sure you read that thoroughly. And it says there, 250 milligrams per 1 mil. So that is your concentration. So that's the number that you're going to have to use, or that's the information that you're going to need. Okay, so 1 mil is 250 milligrams. And if I set this up right, my milligrams will cancel out. 400 times 1 divided by 250. If you did that math, it's going to be 1.6 milliliters. Okay, so read your labels very carefully.
All right, moving along. We're just going to do a little reinforcement with our dimensional analysis.
Slide 27. All right, order is for hydralazine 10 milligrams, IM QID. The strength in the vial is 20 milligrams per milliliter. How many milliliters of this antihypertensive will you administer? So again, we're solving for volume, which is going to be the milliliters. So let's put that in our little answer area, and let's build our problem. Our order starts with 10 milligrams. And it is supplied with 1 mil. Remember, I want mils on top. And it's 20 milligrams is how it comes. It's 20 milligrams per 1 mil. The milligrams will cancel. 10 times 1 divided by 20. And if you did the math, it's 0.5 milliliters. Okay? All right, just like number 2. All right, the order is for Christian. You got 5 micrograms per kilo subcutaneous daily. The vial reads 300 micrograms per 1 mil. The client weighs 39 kilograms. So how much will we administer? So we need to figure out our dose for our weight. Okay, so we have to add that in there as well. But we're ultimately just going to end up with milliliters. We need milliliters on top by itself. So let's build our problem. Okay, so we have our client is 39 kilos. And the medication comes 5 mics per 1 kilo. And then our medication comes 1 milliliter and 300 micrograms per 1 mil. And we should be able to cancel everything out and be left with just milliliters by itself. This is a microgram. All right, so our kilos will cancel, our micrograms will cancel, and I'm left with mils by itself. So I know I've built my problem correctly, so now I can just do the math. 39 times 5, my handwriting is a little sketchy, times 1 divided by 1 divided by 300, and your answer should be, if I punched in all my numbers correct, 0.65 milliliters. Some of those take some time and some practice, but the whole key is building your problem correctly. You have to set up your problem to solve for what the answer's asking you, okay? All right, so I encourage you to practice that.
Okay, moving along. There is some additional practice problems for you for practice set 3, along with the answers. So feel free to access that PowerPoint and do those practice problems. Remember, the more practice you have, the more proficient you will be. Part 4. Now we're moving into IV medications and IV infusions. Infusions and flow rates, again, they're usually going to be measured in the amount of volume over amount of time. So whether it's drops per minute or milliliters per hour or liters per hour or liters per day, that's a flow rate. How much is flowing over what period of given time? And so frequently, if they're asking you for an IV pump, most IV pumps are programmed for milliliters over hour. Sometimes we'd use a gravity set, and I'll explain that later. It's a set where you actually count the drops into the drip chamber to see how fast it will be going. There's, a couple of different methods. So you'll need to learn how to convert each of these rates into the other to determine how long those medications are going to take to infuse, and to make sure you're infusing it at the right rate. So let's go ahead and move forward to some problems. I did want to kind of explain to you or give you a picture of a gravity system. And most of your IV tubing can be set up for either a pump and or a gravity system. If you look at this picture here, you'll have your IV bag, and then there's something called the drip chamber. And whether it's on a pump or if it's not on a pump, you'll see the fluid dripping into the drip chamber. When we talk about drops per minute, that is that little drip chamber. How many drops are dripping in that chamber per minute? If you do not have a pump, you would use your roller clamp to speed up or slow down your drips. So if your drip is going at 15 drops per minute, you would adjust your roller clamp and you'd count those drops for a minute to make sure it's going at the right rate. This is really kind of an older practice that they did when pumps weren't readily available. Most places will have pumps, and you rarely ever will have to use this practice, but it is still required by the NCLEX for testing purposes. Also, there are a few instances where you may be required to use it. Power outages, I actually have worked once where our generator failed, only for a brief time. And then also there are certain situations, like if your client goes into MRI but you don't have a pump that's compatible to go into that MRI setting because it's, that big magnet. A lot of times that equipment cannot go into that in a radiology room. They may have to go to the gravity system. So you do still have to kind of learn how to put this into practice. Okay. Again, with those gravity systems, no pumps used. You're going to regulate the flow of the IV solution by counting the drips into the drip chamber. Kind of explain that again. The drip chambers, that's the entrance of the tubing. You're just going to calculate those drops per minute. That's considered the flow rate. You're going to roll that clamp up or down to increase or decrease your flow rate. Check the drop. Again, the drop size is not standard. You always have to check with the manufacturer of your tubing to see what the actual drip rate is for a particular tubing. So that's very, very important. And because that's when it says a drop factor, that's the information you're going to need to help make your calculations. I do have a video here. It's not one of my videos. It's a video that was it's a few years old. It's a little dated, but the information is still accurate. I do encourage you to pause the video, access the PowerPoint, and please go ahead and listen to that video at your leisure. I'm not going to go ahead and play it now, but I encourage you to go and watch it when you have a moment. All right, this is kind of an IV pump. It's an older IV pump, but that's a picture of an old IV pump. Every facility will have their own specific different kinds of IV pumps, and that will be something you will learn to use while you during your course of your orientation at a given facility. They are much more precisely able to regulate the flow of fluids versus the gravity system, obviously. And it also gives us alarms that will alert us if our infusions quit working, or if they infiltrate, or if there's a problem. It will give us some alarms. It's a lot of safety devices with those as well. Again, for calculations for infusions, you have 3 basic components. You need a flow rate, the volume of fluid that's going to be infused, and how long is it going to infuse. For most calculations, you have 2 of the 3 things required, and you have to figure out the third. So with dimensional analysis, you don't have to memorize a bunch of different formulas to solve for something specific. You can use the same process to answer all your questions. Okay. And just to review, remember the flow rates, the volume of fluid that enters the client over a period of time, the volume of fluids, how much the client's going to receive, and the duration of the IV is how long is this infusion going to take. All right, so let's go ahead and start with the video on basic calculations of an IV rate.
And slide 35. All right, so now we're stepping up our game. We're getting to those IV flow rates. I know, it sounds a little intimidating. But anytime I ask you for a flow rate, it's either going to ask you for a couple things. Flow is how much volume rate. It's either going to be per hours or per minute. So it's either going to be milliliters per hour, which is what your pumps are typically going to be set at, or it's going to ask you for drops per minute. Years ago and older, sometimes we didn't have all the fancy pumps, and sometimes even when power outages happen, or if your patient's going to MRI and you can't take your pump in there, they have things that you can dial, and you'll have to count the drips to make sure it's going at the appropriate rate. So that's why you still have to learn drops per minute. It is still practice, and it is still required for the NCLEX exam. Right now, we're just going to start off with milliliters per hour. Okay? All right, so flow rates. The order is for 1,000 milliliters IV in 24 hours. So you've got 1,000 milliliters that needs to be infused in 24 hours. It's asking you, what are you going to set your pump at? And that's going to be milliliters per hour. All right, so I am solving milliliters over hour. Remember before I only just had the top thing now, but now I'm using both. I need to make sure I'm left with milliliters by itself and hours on the bottom. And these are pretty simple. We're starting out with some basic stuff. So the order again is for 1,000 milliliters in 24 hours. I don't need a conversion because I'm already in hours per milliliters, right? So you're just going to have to do the math. 1,000 divided by 24. And that's going to be, if you do it, it's going to be 41.6. But you'd probably want to round that up to 42. Okay? And again, depending on what test you're on or what exam you're taking, it should tell you when to round and when not to round and how to express your answer. If it says to express it in tenths, then leave it here. If it says to express as a whole number, you're going to move it up to here, okay? So just kind of go by what the question asked you. All right, let's move on to the next one. A client has ordered 120 milliliters in 90 minutes, so calculate the flow rate in milliliters per hour. So we're going to have to put a conversion in here with this one. But again, we're asking you to solve for milliliters over hour, okay? So let's set up our problem so we're solving for mils over hour. It starts off with 120. I'm going to put milliliters up top because I want it up top, but I've got 90 minutes. That's what my order says. But I need to change this to hours. So how many minutes are in an hour? 60. So I've got 60 minutes in 1 hour. And my minutes will cancel out. That exponent is gone. I'm left with hours and milliliters, which is exactly what I want my answer to be in. And so I know I've built my problem correctly, so I can do the math. 120 times 60 divided by 90, and my answer is going to be 80. 80 milliliters per hour. That's what you'd set your pump at. All right, moving on to the next question. Question number 3 of 4 for this slide. Order is for LR to infuse at 167 milliliters per hour for 6 hours. How many milliliters will this client receive in 6 hours? So you're thinking, well, we haven't done stuff like this before, have we? So we just need to set up our problem appropriately, right? All right, so we're solving for milliliters, right? We want to know how many milliliters in 6 hours. And you could obviously just multiply times 6, but let's set it up with dimensional analysis because you can do it. Okay, so we have 6 hours. That's how long it's infusing, and it's going at 167 milliliters for 1 hour. You can set it up that way. Your hours will cancel, and if you do the math, it's going to be 1,002 milliliters total. Okay, you're left with just milliliters, which is what your answer should be expressed in. You can use dimensional analysis to solve nearly anything. Okay. All right. Moving right along, last question on this slide. We've got D5W, which is dextrose 5% in the water. It's been infusing at 30 milliliters per hour for 8 hours. So how many milliliters have infused? So again, we need to answer for total milliliters. So that's going to be our answer over here, total milliliters by itself. That's what it's asking us. But it's been going for 8 hours. And how fast has it been going? It's been going at 30 mils in 1 hour. So if you do your math, 80 times 30 divided by 1, and that's going to be 240 milliliters total. And again, your hours will cancel out, so you're just left with mils. So you know you built it correctly. All right.
Okay, moving right along. We're going to do a few more flow rates.
Slide 36. Okay, more flow rates. All right, so on question 1 on slide 36, it says the order is for 0.9% normal saline, 500 milliliters at 125 milliliters. How long will this infusion take? Now, I want you to think about this because there's a lot of numbers in that question, but you don't need all of it. And frequently, that's how you're going to be supplied things. You have to figure out what information do I need to solve my problem. So we're asking how long. So I want to know how many hours. I'm solving for hours. So that's what I need to solve for, hours by itself on the top. And my infusion says it's going 125 milliliters in 1 hour, and I've got 500 mils. So let's set this up. So the total that I have to infuse is 500 mils. And wants to know how long will it take to put this in our client if we're running it at 125 milliliters per hour. Okay, so if I set up my problem like that, my mils will cancel out and I'm left with hours by itself. I've used all that information in my problem, and we'll go ahead and solve it. 500 times 1 divided by 125, and that will be 4 hours. Okay, so I'm left with hours all by itself. All right, number 2. We've got 1/2 normal saline, 1,000 mils at 50 mils per hour. The IV starts at noon on Monday. What time will it finish? So we want to know how long will it take that 1,000 milliliters to be infused if it's going at 50 mils per hour. So again, I'm solving for how many hours. Before I can calculate the time, I need to know how many hours it is so I can add up the time, okay? So it's 1,000 milliliters. And how fast is it going? It's going at 50 mils in 1 hour. And if your mils will cancel, I'm left with hours by itself. So 1,000 times 1 divided by 50, that will leave us with 20 hours. So if it starts at noon on Monday, what's 20 hours later? And remember, we have to do military time. So 20 hours from noon on Monday is going to be Tuesday at 0800. Make sure you use your military time. Okay.
All right, moving along. Now we're going to go ahead and show you how some drip fractor conversions for gravity systems are set up and done with dimensional analysis.
All right, slide 37. All right, so now we've learned about volume. Remember a few slides back, I talked to you about if it's asking you for the rate, it's either going to be milliliters per hour, typically, or it's going to be in drops per minute. Well, now we're going to solve for drops per minute. And again, as we're just adding more and more into our problems, they're just going to get longer and longer. So we're going to do some practice with that. And this is where dimensional analysis, again, just comes in really, really handy for this. All right, so question 1 of 3 says ordered is 1/4 normal saline. You've got 850 milliliters to infuse in 8 hours. The drip factor of your IV set is 10 drops per milliliter. So that means it takes 10 drops to make 1 milliliter in that particular IV set. So we need to calculate the drops per minute so we know it's going at the proper rate. Okay? All right. So we're answering for drops per minute. So I need to make sure our answer is it drops over minute. That's what we're solving for. So let's set up our problem to solve for that. All right, so it is 850 milliliters in 8 hours. 850 milliliters in 8 hours. That's what we're given. Okay, my drop factor on my IV set is 10 drops per milliliter. And look, I have drops here, so I know I want to put drops on the top. So 10 drops in 1 milliliter. So let's see where we at. My milliliters will cancel out, but I'm left with drops over hour, but I'm solving for drops per minute, so we have to add that conversion in there. And I know you're already thinking, oh, it's hours to minute. So let's take hours, convert it to minutes. 1 hour is 60 minutes, right? Cancel out your hours, and you have drops left over minutes. Everything else is taken care of, so you know you've built your problem correctly because this is all you're left with. So now it's safe to do the math. We'll multiply everything on the top, we're going to divide by everything on the bottom, and that will give you your answer. So 850 times 10 times 1 divided by 8 divided by 1 divided by 60, and your answer would be 17.7 drops per minute. But if you're thinking, how do you do 17.7 drops? You obviously would have to round that one up. But again, just look at what your test is asking you to do on whether to round or not, or how to express your answer. In this particular problem, you would express it as a whole number. That's 18 drops, because you really can't have 17.7 drops. Okay? All right, so let's move on to question number 2 on our slide. All right, ordered is D5 1/2 normal saline IV to infuse at 21 drops per minute. The drop factor is 20 drops per mil. Now it's asking us, how many milliliters per hour is this client receiving? So we have all the drop factor information, but now we have to convert it to milliliters per hour. So we're kind of working backwards. Again, dimensional analysis, you can do that. You just have to build your problem to answer what it's asking you. So I'm solving for milliliters over hour. Okay? And let's see what information we're given. All right. We are giving that it says 21 drops per minute, so I'll start with that. 21 drops over 1 minute. That's how fast it's going. And the drop factor on my IV set is 20 drops per milliliter. Well, I know I want milliliters up top, so I'm going to put 1 mil up here, okay? And I've got 20 drops down here. And that works out great because now my drops will cancel out, but I'm left with milliliters over minutes. So now I just have to factor in a conversion. And you should probably be thinking, you know what that is now, don't you? So we've got 60 minutes to make 1 hour. So our minute exponent can go away, and I'm left with milliliters over hour, and that's what it's asking us to solve for. So you know you did it correctly. So 21 times 1 times 60. Divided by 1, divided by 20, divided by 1, and your answer is going to be 1,002 milliliters per hour. I should make more space, but that's 1,002, or 1,000 if you were rounding, if it asked you to. So about 1,000 or 1,002 milliliters per hour. That's what your answer would be. I encourage you to practice. The more you do these, the more it just comes secondhand, okay? All right. Question number 3 of 3. How many milliliters of D5W will infuse in 10 hours at the rate of 13 drops per minute? The drop factor is 15 drops per mil. So we need to solve for milliliters per hour, okay? And then we'll multiply that times 10. So I need to get here, and then I can multiply that times 10 because it's asking for 10 hours. All right, so what information do we have? It's infusing currently at 13 drops in 1 minute. And then you've got 1 mil. Remember, I'm going to put my mil up here to match up with what my answer is going to be. 1 mil, our infusion set is 15 drops. Okay. And now I've got minutes, but I need hours. So I'm going to do 60 minutes. Is 1 hour. And now I have solved for milliliters per hour. Let's just make sure everything cancels out. My drops will go away, my minutes will go away, and I've got mils over hour, which is what I'm solving for, so I can go ahead and do my math. 13 times 1 times 60, divided by 1, divided by 15, divided by 1, and that answer would be 52. But it's asking, well, how much is going in 10 hours? So it's going to be 52 times 10. So our answer would be 520 milliliters in 10 hours. Sorry, my handwriting is not the best, but I think you get the gist. Okay.
Okay. I just want to kind of just throw a little disclaimer out there. Obviously, on the second problem on the video, I had that wrong. It should be 63. I think I had my answer key when I was doing the videos up there. I think I had the wrong number written down, but I do have it written out here correctly on the slide. It'd be 21 times 1 times 60 divided by 20, and that should give you an answer of 63. Okay, so now we're going to go ahead and move on. Again, more practice set for you. If you have any questions, please don't hesitate to ask. Feel free to pause, download those practice problems, and check your answers. All right, moving on to section 5, IV flow rates and dosage rates. In part 4, again, we learned about those flow rates. Now we are going to add some solutions, not just plain solutions, but we're going to have solutions that actually have medications in them. We're going to calculate dosage rates. It's like how many milligrams or micrograms someone's getting over a certain period of time. The dosage rate, again, is how much of a drug for how much of a period of time. So how many milligrams per minute or units per hour, so on and so forth. A compound rate would be something that is weight-based, like milligrams per kilogram per minute or micrograms per minute. Primary IV, that's just something that's going to provide continuous amount of fluid for the client. A secondary line, frequently they call that an IV piggyback. Those are usually used to deliver intermittent medications. It may also be continuous medications if they need more than one. And they're often either piggybacked in or attached to a primary line. Saline lock, syringe pumps, and volume control sets. Those are burette sets. You don't see those very often anymore. They use those in pediatrics. They should go over some of this information with you in your pharmacology class. If you have any questions, please don't hesitate to ask your instructor. All right, IV piggyback. Again, when we give an IV piggyback, it's usually a second administration set that is piggybacked right into the primary line. The primary line is always going to be hung lower because we use gravity to help infuse our medications when we have two kind of going in at the that are hung at the same time. Anything that is higher on that IV pole will infuse first. That's gravity at work. Again, it looks a little intimidating, but the first time you set that up a few times, it makes a lot more sense to you when you actually get your hands on it. Remember, when your piggyback is going in, your primary is not. So both of those fluids will not infuse at the same time, especially if one is higher than the other. They will, the one that's going on, that is on the higher end of the, at the higher end of the IV pump, will infuse first. Okay. All right, so let's go ahead and look into some dosage rates.
Slide 42. All right, so now we're going to find the dosage rate. In section 5, most of the answers are actually on the slide already, so you're just going to kind of see me work through the problems, okay? So question 1 here, there's a part A and a part B. Part A wants us to find the IV flow rate measured in milliliters per minute. So I am looking for my answer to be in mils over minute, okay? And it is 50 mils in 20 minutes is what the order says. So how many milliliters per minute would that be? And obviously it's pretty easy just to do the math. 50 divided by 20, and that's going to be 2.5 mils per minute. Nothing cancels out. It just crosses over. Okay? All right. Part B of that question, though, says find the dosage rate measured in milligrams per minute. So now we're going to kind of switch it up and see how many milligrams per minute this client is getting. So we have milligrams over minute. Okay? And he's getting 300 milligrams, or she, whoever, again, in 20 minutes. That's our time. And you're just going to divide. And 300 divided by 20 is going to be 15. Very basic, but you're going to use these principles later in some problems that are much longer. Okay? Okay, that's it on that one.
All right. I'm going to go ahead and move on to the next slide.
Now we're converting IV dosage rates to flow rates. So let's start with this. We have like three parts to this problem, or three questions it's asking us to do. We're kind of breaking it down. The order says for Cefoxtin, 1 gram IV piggyback Q6 hours over 30 minutes. It arrives from pharmacy 1 gram and 50 mils. The first thing we want you to find out is what is the dosage rate in grams per hour. So we're going to solve for grams per hour. Okay, so set the problem to answer for grams over hour. Okay, what information do we have? We have 1 gram, and it's going to infuse in 30 minutes. That's what our order says. If you kind of read through there, we've got 1 gram as our total, and it's going to infuse in 30 minutes, but we need to just put our conversion in. So we're going to do 60 minutes and 1 hour. Our minute exponent will cancel out. I'm left with grams over hour, which is what I'm solving for, so I can do the math. 1 times 60 divided by 30, and that's going to leave us 2 grams in 1 hour. So part A of that problem is solved. B. It says change the dosage rate and flow rate into milliliters per hour. So now I'm solving for milliliters per hour. Okay. Remember before we went ahead and did this math. We've got 2 grams, because it's asking us to build off of this. 2 grams in 1 hour. It says change that dosage rate to milliliters per hour, which is what we're solving for. So I've got 2 grams in 1 hour. And how does it come? We've got 50 mils. I'm going to put the mils up top because that's where my mils is here. And in this 50 milliliters, there is 1 gram of medication. I had to look again. So I've got 1 gram of the medication. So my grams will cancel, and I'm left with milliliters over hour, which is what I'm solving for. So if you just do the math, you're going to get 100 milliliters per hour. Remember, multiply everything on the top, you divide by everything on the bottom, and that's 2 times 50 is going to be 100. All right. Part 3 of our problem asks us to change the flow rate into milliliters per hour to drops per minute if the drop factor is 10 drops per milliliter. So I'm going to take this information and build off of that. Okay, we're just breaking down some of these problems that we'll be doing. We've got 100 milliliters in 1 hour. We just solved that. Now it wants us to solve for drops per minute. Oh, I'm sorry. Yes, drops per minute. And make sure I was on the right line. So I'm solving for that. So this is what I have. That's what I have to get to. So what's my drop factor? My drop factor is 10 drops per mil. I'm going to put these drops up here because that's going to match my problem. I've got 1 mil down here. Whoops. And then that will cancel my milliliters out. And I'm left with drops over hour. We have one more conversion we can add in there to get to what we need. 1 hour, 60 minutes. Hours will go away. So I know I built my problem correctly. 100 times 10 times 1 divided by 60. And if you do all that math, that's going to be 16.7 drops. Remember, you can't have 0.7 drops, so you're probably going to round this up to 17 drops per minute.
Okay. Okay, and on this one I don't have a specific video to explain how I broke down the problem, but we'll just kind of go over it. The order says for heparin, we've got 30,000 units to infuse 24 hours, a continuous IV stat, which means right away. The pharmacy brings the medication, and it is 20,000 units and 500 milliliters. So our ordered, which is what's desired, they want 30,000 units in 24 hours. So I've set that up. It's supplied by pharmacy, 20,000 units and 500 mils. And I set that up where the units will be diagonal from each other, so those units will cancel out. And I am left with mils over hours. And then if you do the math, 30,000 times 200, or 500 rather, divided by 24, divided by 20,000, your answer would be 31.25 mils. And again, you look at your question to see if you needed to round that up to a whole number or to a tenth. Usually with heparin, they are pretty specific with those doses. All right, moving on to determining the amount of fluid or amount of volume that's infused.
Okay, slide 45. So now we're going to determine the amount infused. It's asking us a few specific questions about a problem. Okay, there's a part A and a part B. It says a client's getting an infusion at 0.5 milligrams a minute. The concentration of the IV piggyback or the medication is 100 milligrams and 200 mils. So there's 100 milligrams of drug and 200 milliliters of fluid. Hopefully I said that right. And it's going at a rate of 0.5 milligrams, which is the concentration per minute, and it wants us to figure out a few things from that information. How long will it take for the client to receive 40 milligrams? So if it's going 0.5 milligrams per minute, how long will it take to get to 40 milligrams? So let's just build that with dimensional analysis. Okay, so I need to end up my question. I'm going to answer it in minutes. It says how long, so that's how many minutes. So we're going to end up with minutes. Okay, and what we know is that we've got 40 milliliters it's asking how long will it take to get to 40 milligrams? And how fast is it going? It's going in 1 minute. We've got 0.5 milligrams. And if milligrams cancel out, I'm left with minutes by itself. Therein line just answers the question. We just need to do the math. So 40 times 1 divided by 0.5, you guessed it, that's going to be 80 minutes. Okay? Or, you can convert that down into hours and minutes if you want. 1 hour, 20 minutes. All right, and then part 2 says how many milliliters will this client receive in 30 minutes? So again, it's asking us to solve for milliliters by itself, okay? So in 30 minutes, how much volume is he getting in 30 minutes, he or she? And it's, how fast is it going? It's going 0.5 milligrams in 1 minute, and that will get rid of my minutes. And how much volume per milligrams is it? We've got, or milligrams per volume, we've got 200 milliliters, that's our concentration, and 100 milligrams, all right? So that will get rid of my milligrams, and I'm left with mils by itself, which is what I'm solving for, so I know I built my problem correctly. 30 times 0.5 times 200 divided by 100, and if you do all the math, that's going to be 30 milliliters, okay? You just have to learn to set up your problem just to answer for what it's asking you. And again, just get in that practice and kind of work those things out. And again, if you get stuck somewhere, don't forget to don't hesitate to reach out to me or your instructor. We'll help you work through it. Okay.
All right, moving along. We are almost done. Now we're going to determine the amount. Let me adjust my screen here so you can see the full thing. Whoops, excuse me. All right.
Slide 46. Now we're going to talk about units, and I know we've used those before. Remember, it's just an expression of measurement, okay? Our question says, a client is receiving an infusion of a drug at the rate of 3 units a minute. IV piggyback. The bag contains 250 units of the drug and 100 milliliters of solution. So that's our concentration. The question first asks us, how many units will the client receive in 20 minutes? So I'm solving for units by itself. I want to know how many units. We don't write U anymore. We have to spell out units. All right, and it's asking for 20 minutes. So I'm going to start off with 20 minutes. This is what I have. I need 20 minutes. And it is going at a rate of 3 units, units per 1 minute. And then if you do 20 times 3 divided by 1, that's 20 units for 3, and that's going to be 60 units. That's going to be a total of 60 units. Remember, minutes will cancel out, so we've solved for units. Okay. Now, part B of this question asks us, how many minutes will it take for 50 milliliters of the solution to infuse? So it wants to know, how many minutes will it take for 50 mils? So 50 mils of the infusion, but I'm solving for minutes. So how many minutes will it take for this to infuse? So we've got 50 mils, and our rate, again, is 250 units, in our concentration, and 100 milliliters. That's how it comes from the pharmacy. And it's infusing at a rate of 1 minute. That's M, and 3 units. And let's see where we're at. Our units cancel out, our milliliters cancel out, and we're left with minutes. So I know I've done that part correctly. So 50 times 250 times 1 divided by 100 divided by 3, and your answer is going to be 41.6. It's all in how you set it up and spell things right. Okay.
Okay, moving along. IV push rates. This is frequently one of the most difficult problems that students struggle with. And we do it so often. We need to know how safely we can push a medication through a vein when we're giving IV push. Can I do 0.5 ml per minute? it's very important that you get that down and make sure it's accurate, because you can have some really adverse side effects if you don't push it at the proper rate. All right, so here we go into calculating an IV push.
Now we're going to calculate IV pushes. Our first question asks us how many milliliters, and as presented, you've got 750 milligrams of a drug that's ordered stat over 5 minutes. Stat is right away. It's very important. We've got to do it immediately. The concentration of the drug is 75 milligrams per milliliter. So it says find the total number of milliliters you will administer. So how much volume? How many milliliters? So we are solving for milliliters. That's what I'm solving. Just milliliters by itself, over nothing. So what information do I have? I have, in 1 milliliter, there's 75 milligrams, and it's asking us to give 750 milligrams. And so my milligrams will cancel. I'm left with mils by itself, so I know I did the math correctly, so I just have to, or I set it up correctly, so I just have to do the math. Multiply everything on the top, divide by everything on the bottom, and your answer is going to be 10. That's 10 milliliters that will give IV push. All right, and the second part of that says determine the IV flow rate if you divide the infusion into 5 equal segments. All right, so it asks us to kind of break this down a little further, because you know, in nursing, we ask you to push things over 5 minutes or push things over 10 minutes, and then you've got this volume, and you have to figure out how fast you can safely push, how many milliliters per minute can you give it. So this is kind of one of those questions where we're going to figure that out, okay? So push rate in 5 segments. Remember, I've got 750 milligrams. That's our total, and we want to know in 5 segments, or I'll just put it 5 minutes, okay? In 1 mil, this is our concentration, we're at 75 milligrams. And remember, if we just do all of our math, because I want to know how many milliliters per minute, that's what we're solving for. I guess I should put it out there ahead of time. How fast can you push, or how many mils can you push per minute? That's what I'm solving for. Our milligrams will cancel. You've got 5 minutes here, 1 mil here, everything will cancel out. And if you do your math, 750 times 1 divided by 5 divided by 75, and that's going to be 2 mils per minute that you can safely push that medication. Okay, hopefully kind of read through that again, because I know I didn't put those up there right away, but that's real important. That's one of those questions that nurses typically, or nursing students, struggle with on the exams, on how many milliliters to safely push over a given amount of time. So practice that a few times.
Okay. All right. Our last 2 videos go over more additional information with IV push rates. Okay. We'll play the first part.
All right, so we're going over some more IV push rates. And again, I know this can get a little confusing, so I'll try and break it down for you a little bit. The question says the order is for Cepazox, 1,500 milligrams IV push, stat over 4 minutes. The 2-gram vial has a strength of 1 gram per 10 mils. I want to read that again. The 2-gram vial has a strength of 1 gram per 10 mils. Frequently, students will want to put that 2 grams in there. That's just how much it contains, but your concentration of it is still going to be 1 gram in 10 mils. That's the information you're going to need to solve your problems, okay, typically. But just look at what you're answering for. Number 1, it says find the total number of milliliters you would administer. So I need total milliliters. That's what we're solving for, total mils on the end. So I need to build my problem that's going to give me little milliliters all by itself, okay? So, and it says we're going to give 1,500 milligrams over 4 minutes. So we're giving 1,500 milligrams. That's how much the dosage is. How much of volume is that in 1,500 milligrams? So what, again, is our concentration? 2-gram vial, but it's 1 gram per 10 mils. And that's the information you need. So 10 mils, because remember, I want mils on top. And it's going to be 1 gram. So it looks great so far, but we still need a conversion. Remember we did those conversions a while back? So we're going to take our 1 gram is 1,000 milligrams, right? You're going to cancel your milligrams out, cancel your grams out, so you know you built it correctly, because now all you're left with milliliters, and that's all we need for our answer, so we can do the math. 1,500 times 10 times 1 divided by 1,000, and our answer is going to be 15 mils. Okay, 15 mils. All right, part 2 of this question says, let me erase this real quick. Determine the number of milliliters you will push during each 30-second interval. So it's asking us how much will we push every 30 seconds. So to make it easy, I'm just going to break it down to 1 second interval and then multiply times 30. It's just going to make it a lot easier for us in the end. So we're going to get to that 1 second interval. So I want to know how many mils per 1 second. And then I'll just multiply that times 30. Okay? All right. So remember, we have, our order says we've got 1,500 milligrams of this medication in 4 minutes. That's how much, that's how the concentration that we're going to push in 4 minutes. How does it come? We've already decided it's 10 mils and 1 gram of medication, or 1 gram of medication in 10 mils. Remember, I put my mils up here because that's what I went over there. And you see already, I've got milligrams and grams, so we need to put that conversion in there. So we're going to go 1,000 milligrams is 1 gram, and now my milligrams are gone, and my grams are gone, but I'm still left with minutes over mils, and I need seconds. So we need 1 more. 1 minute is 60 seconds. So let's get rid of our minutes. Am I left with seconds, mils over seconds, and I got mils over seconds, so I built my problem correctly, so now let's just solve it. So if you do the math, 1,500 times 10 divided by 4 divided by 1,000 divided by 60, that's going to bring a grand total of 0.0625, that's 2 mils per 1 second, but we are going to multiply that times 30. So our answer is actually going to be 7.5 milliliters. If you multiply that times 30. Okay, you just need to break it down to that singular exponent there.
Okay, and we're going to go on to the second video.
Here, this question is asking us how many seconds per 1 milliliter of fluid. And most questions wouldn't ask you something like this, but again, with dimensional analysis, you can answer that question. We are going to use the information we got in our last part B of that, which is the 0.625 mils per 1 second. So for 1 mil, this is what we're solving for. And we have, remember, we have in 1 second, we have 0.0625 milliliters, right? And our mils will cancel out. And we're left with seconds. So if you do the math, 1 times 1 divided by 0.625, looks a little strange, but when you do that math, it actually ends up to be 16 seconds. Okay, so you can do 1 mil every 16 seconds. Okay, all right.
Okay, moving along. Compound rates. These are rates that are figured out mathematically by weight per kilogram. Remember, we typically do our weights in kilograms, so you'll always have to convert your pounds into kilograms when you're figuring out a dosage for a client. So here is our video.
Slide 51. All right, so now we've gotten to compound rates, and this is probably one of the most difficult problems that you're going to have to solve, because typically you're going to have to figure out a weight, micrograms, conversions, maybe even drops per minute. There's lots of things going on, but remember, you build your problem for what you're solving, and that's the hard part, is just trying to build that problem for what you're trying to solve. All right, so let's see what it's asking us. Our question asks us, ordered. A client weighs 80 kilograms and is ordered dopamine at the rate of 3 mics per kilo per minute. So let's figure that out. Let's go ahead and just get our dose first, because sometimes when you put the kilograms in there, it doesn't always work out like it wants to, especially when you're doing a weight-based dose. So rule of thumb, if you're getting something like this, I would always figure out your specific dosage for your patient first. So if we have 80 kilograms, that's how much our client weighs, and the order says 3 mics, and it's per 1 minute, or I can take this down here, per 1 minute. Oops, 1 minute. And if you do that math, that's going to be 240 micrograms per minute. This is the dose. Sorry about my handwriting. This is the dose that's specific for our client. So now that we have his dosage information or her dosage information, we can hopefully solve anything else that it's asking us. So now we have our dose. Okay, I'm going to leave that there. I want to make that 2 look like a 2 though. Whoop. Christ. Okay, let's fix that. Make it somewhat legible for you. Alright, so part 2, it says how many micrograms, or part 1 says how many micrograms per minute should the client receive. We've done that part. It's done. So now it's asking how long will it take for the client to receive 50 milligrams of the drug. So let's say how long. So I'm going to go ahead and solve for hours. You could solve for minutes, but I'm going to go ahead and solve for hours. Okay, because we're in micrograms, and I think it's going to be a rather large number. So I'm going to go ahead and solve for hours. All right, so it's asking us to solve for 50 milligrams. Okay? So what information do we have? We know it's got 240 micrograms in 1 minute. But I am going to go ahead and kind of flip that around here because I want to make sure my time, when I do my conversion, I want to make sure my hours is on top. Okay? So I've got 1 minute up here, and I've got 240 micrograms. Okay? That's what I solved for on my first part of my problem. All right, so let's go ahead and put in our conversion. We've got milligrams to micrograms. So 1 milligram is 1,000 micrograms. That's CG. And now I got these will cancel, this will cancel, but I'm still just left with minutes. So I have to add one more thing in there to get just hours. Okay? So I've got 1 minute up here. To convert that to hours, I've got 60 minutes. In 1 hour, now my minutes will go away. That's an R. And it looks like I built my problem correctly because I'm left with just hours by itself on top. So we'll do the math. 50 times 1 times 1,000 times 1 divided by 240 divided by 1 divided by 60. And that's going to be 3.47 hours. Now be real careful when they ask you, how to express your answer, because this isn't 3 hours and 47 minutes. This is 3.47 hours, or almost 3.5 hours. So you may have to convert that out farther. And if you need help with that, I can help you with that or show you how to do that in a later video by request if you want me to. But it figures out to be about 28 minutes, almost a half hour. So just be real cautious as to what your answer is going to be expressed in. Okay, and that's it for that one.
All right, we are just about done. Hopefully you found some of those valuable and helpful for you for your dosage calculations. Again, here's a couple practice sets with some answers for you to check your problems. It's all set up in the dimensional analysis method. If you have any questions, don't hesitate to reach out to myself or one of your instructors. Eventually, I will be going over pediatric dosages. That will have to be at a later time, and I appreciate your patience. Have a great day.